welcome to EasyVTech. Please subscribe our channel and share to your friends also. Myself, Ravi Kumar. In this video, I am discussing about the series connection and parallel connection. That is, it is the main basic reduction technique which is helpful to find out the equivalent resistance in the given circuit. That is, how to find out the total resistance in the given circuit by applying series connection as well as parallel connection. Okay, now, before going there, you must understand what is the series connection and what is the parallel connection. Okay, in that, the first connection is series connection. In series connection, what are the main properties? Current value is same as well as voltage is different. That is, voltage division takes place, but the passing current, the flowing current in the series connection in the series circuit is same. Further, consider we have three elements. For example, you have to consider three elements. That is, you have to take three elements. Okay. First one is R1, second one is R2, third one is R3. We have to consider three elements. Then, what is series connection? That is, the second endpoint of the first element is joined with the first ending point of the second element. Similarly, the second endpoint of second element is joined with the first ending point of the first element. Okay, like that, if R1, R2, R3 are connected side by side without any intermediate node, that connection is called as the series connection. Then, across these nodes, you have to find out what is the equivalent resistance in case of series circuit. Okay? That means the formula for equivalent resistance in case of series circuit is the sum of all resistances values, that is R1 plus R2 plus R3 in the circuit. Suppose we have R4, R5 like that, then we can add all resistance values, that is the equivalent resistance value in case of series connection. Suppose that is taken as suppose node point. For example, in the similar manner, the inductance L1, L2, L3, and so on, Ln are connected in form of series connection. Are connected in series connection. Then how to find equivalent inductance? The same manner, we know the voltage drop across inductance V equal to L into di by dt. That means the voltage is proportional to inductance. That's why the equivalent inductance in case of series connection is also the adding of all inductance values. That is L1 plus L2 plus Ln. That is in case of resistance inductance values. Similarly, if capacitances are connected, that is C1, C2, and so on, Cn are connected in the form of series. Then how to find out equivalent capacitance? Okay, but we know that is the voltage is proportional to the 1 by C. Okay, that's why in case of series connection, the equivalent capacitance value is 1 by C equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3 and so on. Okay, these are the formulas for in case of series connection for resistance elements, for inductance elements, for capacitance elements. Okay, remember in case of resistance inductance, the equivalent values are sum of all elements in series connection. But the capacitance will be the reverse of the capacitance. That is 1 by C equivalent equal to 1 by C1 plus 1 by C2 plus and so on. Okay, that is the equivalent formulas for in case of series connection. Okay, that is in series connection, current is same. That's why all elements are to be added. In the similar manner, the second connection is parallel. That is what is meant by parallel connection. Okay, in parallel, that is voltage is same, but current division takes place. That is, current value is different in case of parallel connection. Okay, then what is mean by parallel? Okay, same in the same manner. For example, three elements are connected in parallel. For example, okay, that is we have take R1 one element, R2 second element, R3 third element. Okay, for example, R1, R2, R3. Okay, what is parallel connection? How to form R1, R2, R3 in parallel? That means all first ending points of the elements are joined together. Similarly, the ending second ending points of elements are joined together. Then that connection is called parallel connection. That means R1, R2, R3 all are connected between the same nodes. Upper node is same and lower node is same. Across the same nodes, three elements are joined. That connection is called as parallel connection. Across that point, you have to find out equivalent resistance in case of parallel connection. Okay. Then the formula for parallel connection is that is 1 by R equivalent equal to. That means in parallel connection, current is division takes place. That's why I equal to V by R. That is 1 by R should be possible. That's why the equivalent value is nothing but 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, this is the formula for in case of resistance in parallel connection. 1 by R equivalent. Okay, don't remember. Most of the students are writing here R equivalent equal to 1 by R1 plus 1 by R2. Okay, it is wrong. Then you have to write down 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. If only we have two elements are there in parallel, R1, R2, the formula simply is that is R equivalent equal to R1, R2 by R1 plus R2. So take LCM, then you have that formula. Okay. Similarly, if inductances are connected in parallel, okay, that means L1, L2, and so on, Ln inductance are connected in parallel. That is the same formula will be applicable. That is 1 by electron equal to that is 1 by L1 plus 1 by L2 plus and so on 1 by Ln. Same end of resistance values. Okay. In the same manner, if the capacitances are connected in parallel, okay, capacitance value will be different. Okay? That is C1, C2, C3, and so on, Cn are connected in parallel. Okay? In parallel connection, the capacitance, equivalent capacitance value is nothing but adding of all capacitances. That is C1 plus C2 plus and so on, Cn. Remember, the capacitance formula in case of parallel connection is adding of all elements. In case of series connection is reverse formation. So that is only different for capacitance. Okay, na? These are the series connection and parallel connection formulas in case of resistances, inductance, and capacitance. Okay. For example, here take one example problem which is combination of series and parallel connection. Okay. For example, I am taking the one problem here. Okay. Three elements are joined here. Then total circuit will be connected to a source value. That source value is taken as 30 volts. Okay. Then first resistance value is 5 ohms and second one is 4 ohms and 2 ohms and 4 ohms. So for example, this circuit, it is combination of series and parallel. For example, three elements are taken, four elements, 5, 4, 2, 4. Okay. Then we have to understand what are the elements are connected in series and what are the elements are connected in parallel. Okay. From this circuit here, our aim is to find out, that is to find out total current and total resistance value. Our aim is to find out total current and total resistance. Okay, na? Before going to find out total current value, we have to find out what is the equivalent resistance in the given circuit. Okay, na? Then all of you understand the problem here. That is 4 ohms, 2 ohms, and 4 ohms. Then the three elements are like that in the form of parallel connection. Why? Because the three elements are joined across same nodes. That's why we have to find out, for example, R1 equal to 4 in parallel with and 2 in parallel with 4. Okay, na? That value you will get the, that is 1 ohm. That is 1 by R1 equal to 1 by 4 plus 1 by 2 plus 1 by 4. That equal to R1 equal to 1 ohm you will get. Then simply after simplifying that three elements is, then what is the equivalent circuit should be changes? The circuit will be changes like this. That is 5 ohm. That total value will be changed as 1 ohm. That's 5 ohm. Okay, na? Then how to look at here? 5 ohm and 1 ohm are connected in the form of series. Okay. Therefore, equivalent resistance, total resistance in the circuit is for series connection. What is formation? Adding of all elements. That is 5 ohms plus 1 ohms. Then equivalent resistance will be 6 ohms. Okay. That is in the given problem, total voltage we know 30 volts and total resistance we are find out, that is 6 ohms. Okay. From that, we have to find out total current, that is I equal to V by R according to Ohm's law. That's why I equal to total voltage by total resistance, that is R equivalent. What is the total voltage given? 30. What is the total value? R value, that is 6. That is 30 by 6. We have total current in the circuit is 5 ohms. Okay, na? In this way, we have to find out the our required response. Response means our finding value. What is the finding value? Then, then we understand what is the connection of parallel, what is the connection of series. Okay, most of the students, that is, if the resistances are connected in like that, that is the in column wise, it is a parallel. If the resistance are connected in the form of horizontal, it is a series. You know, that connection should be, analysis will be wrong here. You know, don't like that here. If the resistances are connected horizontal, it is series. If the resistances are connected in a vertical, it is parallel. You know, not like that. If the elements are joined one by one with the same current is same, then that is called series connection. If the current is dividing, that is called the parallel connection. Voltage is same. In parallel, voltage must be same. In series, current must be same. Okay, remember that here. That is the like that. You have to find out the series connection as well as parallel connection. Okay, that's right. Please subscribe our channel, then and share to your friends also.